Welcome back. This is Professor Ridge and today's lesson on section 9.3, logarithmic functions. So we ended last section on graphing x equals 2 to the y, and that's the inverse of y equals 2 to the x. So we're actually going to define this to be the logarithm base 2 of x equals y. Okay, so this is basically where we're going to start building or what's called a logarithmic function. So log base a of x equals the m is equivalent or means a to the m equals x. Okay, so again we got to memorize this. This is the defining statement for logarithms. Let's see if we can figure this out. So log base 10 of 1,000 equals what? So we're saying, so we start with the base. This is the base. Okay, so A is the base. M is exponent. Oh, hang on. Okay, so base is 10. 10 to what power is 1,000? Well, this is easy. We know that's going to be 3. So 10 to the 3 is 1,000. So log base 10 of 1,000 is equal to 3. And I want you to get this ingrained in your head. You're going to hear me say this probably 100 times, but in class I say 1,000 times. You're gonna hear me say this over and over again. A logarithm is equal to, or I just say is an exponent, or you can say equal to an exponent. Same thing. Is equals. Logarithm is an exponent. Okay, so the logarithm of 1,000 base 10 is the exponent of 10 that gets you 1,000. So 10 to the third is 1,000. So remember, a logarithm equals an exponent. So just kind of keep that in your head. So we're asking, what's the exponent of the base that gets you that number inside? So let's try number 12. This is the exercise from the book. So log base 2 of a equals what? So again, 2 to what power? We're looking. Remember, log equals an exponent. What's the exponent of 2 to get you 8? And if you said 3, then you'll be right. So 2 to the third is 8. Number 16, log base 5 of 1/5. So what's log of 1/5 base 5? You can say it either way. So we're saying 5 to what power? 5 to what power equals 1/5? And remember, to get 1 over 5, it has to be negative, and so it'll be negative 1. So number 20, or let's do number 22. Log base 9 of 1. So log of 1 base 9 is equal to what? So again, we're going to think 9 to what power equals 1. And note, anything to the 0 power equals 1, so this must be 0. Okay, and it doesn't matter what the base is. Log of 1, it doesn't matter the base, is always going to be 0. Okay, 26 is interesting. Log base 6 of 6 to the 9 equals. So we're saying 6 to what power equals 6 to the 9th? Well, obviously it's going to be 9. And this brings up a property that we have too. Okay, so here's a couple of properties. That we're going to have to memorize here. So we got log base A of 1, so that's 0. Anything to the 0 is 1. Also, log base A of A to what power is A? Well, that's 1. And then also, then this one here, these are the inverse properties. Log base A of A, the n is just n. And then A to the log base A of, say, x equals x. So if you take any number and raise it to the power that's a logarithm that has the same base, kind of you think of it as like canceling each other and you just get x. And same thing, log base A of A to the n, then they're inverses of each other, so they cancel and you just get the number you started with, or the power n. Okay, so those are some properties of logs that you have to know, right? Okay, so log of 10 base 100. Again, we're going to say 100 to what power equals 10. So let's see, square root of 100 is 10, so that's 100 to the 1/2. So this is going to be equal to 1/2. Now you should get a calculator that has a log button so you can learn how to use it. And I'll show you the change of base formula in a minute, or in a later section actually. So I take that back. Let's try 34. Log of 16. All these you should be able to do without a calculator. So 16 to what power equals 8? And let's see, that is going to be... Now this is a crazy one because here's the way you would do it. You can say if you did the fourth root of this would be 2, and then 2 cubed would be 8. So it'd be 16 to the 3/4 is 8. Yeah, that was actually a difficult one. So fourth root of 16 is 2, and then 2 cubed is 8. So you get 16 3/4 is 8. And then 36, 6 raised to the log base 6. Remember, exponent and logarithms are inverse functions, so those are like canceling each other out. You just get 13. Alright, now graph. Let's try number 40. Y equals log base 7 of x. So remember, it's easier to graph these if you think of it in the exponential form. By the way, using that defining statement about logarithms, the equivalency, so this would be log form, logarithmic form. This would be exponential form. And again, I want you to get this in your head. A logarithm equals an exponent. So this logarithm equals exponent. the number here, this is the base, so I always start with my base. Base is 7. The log equals the exponent, so y is the exponent, and then this number inside is left over there. So remember, what I'm going to do is, it's easier to take the powers, so if I do 0, 7 to the 0 is 1, 7 to the 1 is 7, so see I'm doing it backwards, and then I rewrite it. So if I plug in y's and figure out what x is, that's easier. Or I can think of it the inverse function and then switch the x and y's. You could do it that way too. So if I do 7 to the negative 1, that's 1 over 7. And if you go back and look at 9.2, like the one we did, x equals 2 to the y, it's the same idea. So let's see. Okay, so we're going to do 1, 0, 7, 1, negative 1, no, 1/7, negative 1. So if you remember, it goes like this. So this is y equals log base 7 of x. Okay, which is equivalent to x equals 7 to the y. So it's easier to think of it in the exponential form. Pick the y coordinates, the 0, 1, negative 1, and then plug them into that exponential form. 7 to the 0 is 1, 7 to the 1 is 7, 7 to the negative 1 is 1/7. Plot those points, 1, 0, 7, 1, 1/7, comma, negative 1, and then you make your graph. Okay, so number 48 says write as the equivalent exponential equation, do not solve. So we're just practicing. So we're kind of leading up to the technique is to solve logarithmic equations. You're going to convert it to exponential form, and solve exponential equations, you convert it to logarithmic form. So you do vice versa. So it's important that you can convert back and forth between the two forms. And remember, again, you're going to repeat this. It's going to become your mantra. Logarithm equals an exponent. Logarithm equals the exponent. So y is my exponent for the base 8. So I'm going to do 8 to the y equals, and the only number left over is that 10. Okay? So as simple as that. You just have to get that ingrained in your head. Log equals an exponent. So log, this is the logarithm, equals exponent. 2 is the exponent. The base is 6. So I'm going to write 6 to the second equals 36. And again, it doesn't ask us to do anything else. Just convert it back and forth. So number 56, log base b of n equals 23. So again, log equals the exponent. So base is b, exponent's 23 equals n. Okay, so it's simple as that. Just take some practice. Keep repeating. Logarithm equals an exponent. Logarithm equals an exponent. Start with your base. Get the exponent. Remember, the logarithm equals the exponent. So log base m of p equals a. So we start with our base, m. Log equals the exponent. So a is the exponent. And then the number left over, right on the other side. So we go base to the exponent equals the number inside. Okay, so now we're going to go the other direction. We're going to take exponential form of an equation and write it in a logarithmic form. So number 68 8 to the 1/3 equals 2. So remember, logarithm equals the exponent. So the exponent goes over here. And usually what I do is I write the log, and I start with the base. Base is 8. So normally I write that first. Then I say logarithm equals exponent. Exponent's 1/3, and then the only number left goes inside. Okay, let's try another one. How about number 74? Y to the t equals x. So we're going to write log down. Start with your base. Base is y. Log equals exponent, so the t goes on the other side. And then x goes inside the logarithm. And then one more thing here. Oh well, we'll talk about that in the next section. There's this, what's called the exponential number. We're going to define this in the next section. E to the 2. E is the exponential number. So just, I'll explain it next section. So let's just forget about it for a second. It's not a variable, it's an actual number. So log base, start with the base, E. Log equals the exponent, 2 is the exponent, goes on the other side, and then I didn't leave enough space. So 7.3891 goes in there. Log base E, 7.3891 equals 2. Okay, so again, you're going to start with the base. Log equals the exponent, which is 2, and then the number 7.3891 goes inside. Now again, next section, we're going to introduce you to the natural logarithm, so I'll just go ahead and tell you now. So log base E of any number is equal to L in let's change this to M for any number. Ln of M. Okay? And you'll see this button on your calculator, Ln. And we'll talk about that. This is log base E. Okay, and we'll talk about that later. Alright, so the technique to solve is if it's there's a couple different rules that we can use. One rule is if it's a log equation, you convert it to exponential form and then solve it from there. And if it's a log equation, you convert it to exponential form and solve it from there. Did I say the same thing twice? So if it's a log, convert it to exponential. If it's exponential, convert it to log. So you go back and forth. So I'm going to convert this to exponential form. Start with your base. Log equals the exponent. See, and it's ready to go. Just simplify it. 4 times 4 times 4 is 64. Okay, number 84. Log base x of 12 equals 1. So log of 12 base x equals 1. So start with your base. X logarithm equals exponent, so the exponent's 1. Solve that. So just simplify. So no big deal. How about number 88? Log base 8 of x equals 2/3. So we're going to start with that base 8. Log equals the exponent. That's the exponent. 2/3 equals the number inside. And then I'll just punch 8 and 2/3 in my calculator, or I can do this in my head. Cube root of 8 is 2. 2 squared is 4. So x equals 4. Alright, so that completes the lesson for 9.3. Go to My Math Lab, complete your exercises there. And remember, logarithm equals an exponent. Just keep saying that. Hopefully you can straighten it out. Alright, see you next time.